this is Kenneth Wong, Senior Editor for DE and the author of an upcoming feature story on Cobots, or collaborative robots. For background research, I visited Rapid Robotics based in San Francisco. First, let's get to know the company and its history.
Yeah, so Rapid Robotics began in October 2019 in downtown San Francisco. 6 employees originally. We deployed our first robot within 6 weeks of founding. We've always had this company culture of deploying products to our customers that they want, and we always wanted to make sure that we didn't build something, that would take years to build and then find out our customers didn't want it. We wanted to make sure that we were deploying robots from essentially day one and always iterating our offering to make sure that we connect our product vision and strategy to exactly what customers need.
People have different ideas about cobots, with some imagining humanoid entities in metal and silicone working alongside humans and giving a high five for a job well done. Well, one day we may get there, but that's definitely not the norm for the present in industrial settings.
Yeah, so what we find with cobots versus a traditional industrial robot is, there is some fallacies that are built up in the market when a lot of people talk about it. What cobots effectively do is they can sense force. So if a robot has hit an obstacle or unlikely a person, the robot can stop and not cause any further damage. But the problem is that cobots can also still move very fast. So what does this mean? If a cobot is moving as fast as an industrial robot, you still need all the same safety equipment that you would normally deploy, and the cobot could not necessarily work alongside a person because that cobot has so much energy, it's moving quickly. You can imagine even if a car with really good brakes hits you, the car still hit you, right? So what cobots allow, though, is and how they're different from an industrial robot is that they can move slowly well around another human. And effectively what that does is you can run with less safety equipment that takes up a lot of space and costs a lot of money than what you would normally deploy. Now, cobots working with a human actually in the loop, we've actually seen that to be a pretty rare use case, and the reason is because the speed in which the cobot has to operate in order for a human to be in its workspace at all times is so slow that it actually negates the value of the deployment. Being that if you can imagine a robot work cell living in a facility where parts are coming in to be serviced by this robot, that robot has to do something with that part, and then there's another process downstream from that robot. All of this has to happen at a certain time cadence, and we call that cycle time. In order to meet cycle time requirements, generally the robot has to move at a certain speed. However, if the robot is speed limited because of safety considerations, i.e. it has to move, a human is working with that robot, then a lot of times that the cycle time of that robot falls below the required speed cadence and therefore can't be deployed. So a lot of cobot deployments that you actually see in industry are actually we call cageless deployments. The robot does not have a human in its workspace normally, but if it did have a human, if a human did enter its workspace, the robot is moving at a speed and has the force-sensitive capabilities to slow down or stop before the human actually enters the robot's work cell. Whereas with an industrial arms tend to either use very high payloads or very fast, which means either way it means a lot of energy. Energy is speed times mass. You generally have to have these whole things caged off because even if a human were to enter the work cell and the robot is moving slowly, an industrial robot does not have the force sensing capabilities to detect, for example, if it's crushing a person's hand or anything like that.
Machines have always been part of the assembly lines in automotive factory. What's the difference? How is the current deployment different from the past? The difference is machine learning or AI.
Yeah, so AI helps us in 2 regards. The first is in work cell artificial intelligence and machine learning. So these are things like perception. Where is the part? How do we pick the part up? Where do we place the part? Is there anything in the workspace that would cause an issue in terms of safety or maybe block a motion path? This is all very important, and RAP has developed some key pieces of technology around this, but we also see AI as enabling the deployment process itself. And what this means is using generative AI to actually create the deployment, right? And these are things that happen before the deployment actually reaches a customer facility. It's things like figuring out, well, where should the robot go to optimize cycle time? Where should the machines go to optimize cycle time and cost? What about all the bracketry and all of the structural material that almost always has to be created for these deployments? Can that be automated? Can that be done? Can one of our deployment engineers simply specify what they want in plain language and receive a template back that they can then configure and deploy? We see that as the future of AI and automation, because what we see generally is that while perception technologies are extremely useful and powerful, they don't completely eliminate the actual process of deploying a robot, right? You still need to develop all of these components and and actually perform the deployment, and that's where we see most of the time taken up. So I will tell you, in my experience, I have never actually seen a robot cause someone to lose their job. What we've actually seen is we've seen robots make people's jobs better, more interesting, and more valuable. The reality is in a factory, there are certain jobs that are extremely value add and extremely mundane, right? Additionally, in today's economy, it's actually extremely difficult for factories, and speaking from my logistics experience at Kindred, warehouses, extremely difficult in hiring operators to work in these facilities, especially for the mundane jobs, but also even for the more value-added jobs like inspection or operating a specific machine or anything like that. And what we've seen throughout our entire history of deploying robots, in fact throughout my whole career, is that robots up-level human jobs. We've actually seen that operators who see a robot come in to do the job they are currently doing, they want that because they know there's other jobs in that factory that need to be done that are far more interesting, far more valuable, that they can do, but if only there was a robot to do it.
For more on this subject, read our upcoming March article called Mr. Robot, Lend Me a Hand at Digital Engineering 24/7. That's digitalengineering247.com. For more on Rapid Robotics, go to www.rapidrobotics.com. Thanks for watching. Until next time, this is Kenneth Wong for DE 24/7.